So welcome everybody. My name is Dave Magnall, Innovation Partnership Manager for Seco Tools. And I'd just like to welcome everybody to this session for ITI 2020, Inspiration Through Innovation. And I take great pleasure in welcoming for the first time to this event, Modig Machine Tools and their president, David Modig. Welcome, David.
Thank you so much.
Good. Great to have you here. And alongside David is Jürgen Anderson, application expert for Seco Tools. Jürgen, welcome.
Thank you very much, Dave.
Good. So, David, just wondering if you could just give us a little bit of a history of Modig Machine Tools, how you got started, and where you are now, how things have moved on from that start point for Modig.
Absolutely. A lot of things that's happened over the years. The company was founded 1947 by my grandfather, and it was passed over to my grandmother and my dad, and then me. So I took over the company about 10 years ago. We all have the same, background in the family. We all grew up on the workshop floor, and I have been very, very involved in machine tools. That's really the only thing we have discussed around the dinner table is how machine tools should be designed. So it's been a nice journey, I would say.
Yeah. So it's fair to say that this company is a company that's founded on a real sort of knowledge and experience of the industry then? Absolutely. So really our strong point is the technology and how to design machines. So all the machine design is done by me and previously my dad. So it's been it's a nice job or a hobby. For sure. Great if you could combine those two things. So we're going to see some great technology and some great solutions in this session, but what I want to discuss first is those challenges we see in the industry. You know, what's keeping manufacturers, particularly in large aluminium structures, what's keeping these guys awake at night? What are their pain points? So, David, I'd like just to put that to you first. What challenges do you see in our industry?
The challenges are different depending on what industry we're talking about. About the aerospace, they get more and more challenged by price per part, and automation and special machines like ours are more needed right now. So we see that the industry is moving towards these special machines or dedicated machines more than just the standard equipment. If we go to the automotive side, then it's obviously the electrical vehicle market is gaining a lot of ground, and it's a lot of aluminium extrusion machining and high volume. So that's also a challenge in a different way.
Okay, so there's a lot of top level challenges there. I mean, just to sort of come down into a bit more detail, and maybe Jürgen, you could step in on this, is to look at some of these machining challenges, you know, when we're actually looking at the application or the cutting challenges. What do you think our customers need to overcome when it comes down to that level?
I think when we're looking at this Modig case, and I would say that these extreme machines that they produce to really keep a low cost per part is really, for our point of view, is to handle the cutting forces in the machine, because it's very, very high cutting forces. So I mean, we need to balance, I mean, tool design, to be able to handle the cutting forces. We need to provide consistent process security into this machining, and also to provide very good component quality in the end as well. So that is let's say the main challenges for us.
Absolutely. I mean, there's no good making a component really fast and taking a load of metal out if what you've left with is of poor quality. You know, if the accuracy is not there, or the surface finish isn't great, you know, there's a lot of challenges there.
Yeah,
so,
that's correct.
Just coming back to how we address these challenges then, David, this is back to you. So how does Modig's technology address these challenges of metal removal rate, of quality, of accuracy? How does your technology deal with these challenges? So when we design a machine, we focus a lot on the accuracy, obviously, about the chip removal, acceleration, deceleration, corner speed. I mean, all of these kind of things are very important for us. So when we start the design, we first look at what do we want to achieve in terms of chip removal and still keep the tolerance on the part. And we don't look so much on the part size. We just focus on what is the pressure on the tool, what dynamics do we need, what stiffness do we need. So this is the first step. And the machine we're looking at now, this one has 16.5 liters of chip removal per minute, which is going to create about 350, 400 kilo tool pressure.
Yeah.
So that is a challenge in itself, and to be able to run a machine like this very quickly, but where it's still very heavy, it's a challenge. So a lot of FEM analysis, a lot of testing with the tools and the control system supplier. I would say that's the big part of it.
Yeah. So just stepping away from the cutting side of it, from the sharp end, what other technologies do Modig incorporate into your solution? So we know automation is a big topic now in aerospace, even though it's been around for some time in automotive. So just wondering how these technologies are sort of combined or complemented with your machines.
Yeah, we try to create machines which has a low price per part, and even if our machines are expensive, we many times compare to the cars. If you have a car and you drive around a racetrack and you get challenged and you need to lower your run times around the track, you need better brakes, you need better engines, you need better chassis. Though it's exactly the same thing in the machine world. So this is a little bit what we're focusing on. We have high-end components that needs to be able to brake hard, accelerate fast, and that is really what differentiates us from the competitors right now.
Okay, so just on that accelerating hard, it's just brought to mind a world record that Modig achieved a couple of years ago.
Yes.
Would you just like to tell us a little bit about that?
Yeah,
I'm sure you would.
we actually removed 16.5 or 6 liters per minute, which is about 250 liters of chips per minute. So an oil barrel of chips was removed per minute. So that was amazing. But right now we actually are going to take it to the next level again, and we're shooting for 20 liters per minute right now with the RigiMill, and actually a new machine we're designing. So that is the next step.
That sounds exciting. Just to try and put that into a real world example, David. So say if you just think of a large aluminium rib, what would be the standard cycle time, not on a Modig machine, but if we just took an industry standard large aluminium rib, what would I be looking at?
There is so many ribs, but in general, what we do, which is very, I would say, very different than the other suppliers, is that we have a guaranteed cycle time. A lot of companies, they say guaranteed cycle time, but we guarantee with the money back guarantee in the contract. So right. What we see in average is about 50% cycle time reduction to the really good brands out there. And we're not ashamed of competing with anyone, really. So when it comes to ribs or stringers or spars, for example, I don't think we have had one case where we have been below 50% cycle time reduction so far.
Okay, so the checkbook's been safe so far.
Yes. Oh, yes. That would have been not so good otherwise.
That's good. Jürgen, so looking at all these higher removal rates, I mean, it's all great having the machine, but like you say, there's a lot of challenges around the tool. And I just want to know how Seco tooling solutions complement Modig's machines, and does the design of the machine or the challenges we're facing, how does that influence the design, the technology of our solution?
I mean, we normally we're working very closely to the Modig's application engineers to find the right solutions for the component, and as much as possible we try to solve with our standard program. But from time to time that is not enough, so we really need to do special designs of the tools to handle these cutting forces and to provide the process security when they do the machining of the components. Sometimes it can be just a very, let's say, simple modification of the standard tools to make it more rigid to be able to handle the cutting forces and in the machine. Some other times it's a pure standard tool to be able to handle special radio corners or whatever it can be.
Yeah, I was going to ask just, what are the key features required of a tool to deal with such high metal removal rates? What challenge does taking that amount of material that David spoke about? What do we have to do, or what should we be looking for in a cutting tool to be able to deal with these kind of removal rates?
I mean, normally, if you look at, we can take, for example, a solid Dan mill, it can mean that we need to increase the core diameter, we need to decrease the flute length, stuff like that to make it more rigid.
Okay.
That it's a very good example.
And a lot of these components are aluminium, and people mistakenly think that aluminium is a soft material, therefore easy to machine and doesn't present any challenges. Can you just give a flavor of some of the challenges that the material itself can pose to a cutting tool?
I mean, you can have built-up edge problems. Also, that it's very how do you say? Now I can't really find the English word for it. I mean, for milling, we don't have any big problems with ship breaking as we have in turning operations, but I mean, to have, let's say, the flutes ship evacuation is good. That is also a challenge here. We need to have extremely good ship evacuation. So the flutes need to be very optimized from that point of view as well. And together to balance that with the rigidity of the tools it's sometimes a very big challenge for us.
I mean, this question could go to both of you. I would imagine there's some high spindle speeds involved in this process, and again, how does that influence the design of the tool? I guess there's got to be real sort of focus on producing a quality tool that's very well balanced, because that could then cause a knock-on effect on the spindle of the machine.
That's correct. Jürgen needs to talk about the tool characteristics, but I can talk a little bit about the machine. So, I mean, what we have seen, we have done a lot of testing, and the most amount of chips or material that we can remove is with a 20,000 RPM spindle. Many think that the 30,000 is the way to go, but in the cutting forces on an HSK 63, which is used on a 30,000 RPM spindle, won't be enough. So having an HSK 100, 20,000 will actually remove more chips. But if you have a parts that is a lot of finishing on and not so much roughing, then the 30,000 is better. Okay,
thank you. Jürgen, have you anything to add on the balancing of the tool at all?
I mean, as David said, we need to have a very good balancing on the tools to secure let's say the quality of the work, because let's say avoid the vibrations, everything like that. So I had nothing really to add more to what David said there. So, okay. But I mean, what David said about the 20,000 RPM machine, we normally, if I recall it right, David, you use a HSK 100 spindle in the RigiMill. Yep. And I mean, looking at our, let's say, aluminium cutter, the VPGX insert that you normally use for the roughing operation, you normally use the full length of the insert. So I mean, we can't even push it more than we do today. Then we need another solution as well. So
yes.
Okay. Good. So it seems to me, looking at the Modig machine, that you do things differently. You just tell us what's unique. What are the unique features about your technology, and why have you chosen to take that approach?
I would say the reason why we build machines like we are is because we don't want to compete with standard machine tools in that area, because then it's hard to compete in pricing, and we're more focused on turnkey solutions. We're not selling machines out of the catalog like most of the others. We have the possibility to change the stroke length, the spindle power. Do you want to have it for titanium? Do you want to have the machine for aluminum? So when we design a machine, we focus actually on hard metal machining a lot of the time. So the RigiMill was designed for 0.9 liters of chip removal or material removal in titanium. And that is actually giving you a cutting force of 4,500 kilo on the tool. So all the FEM analysis and everything was done with that in mind. So it's I wouldn't say overkill for aluminum, but it was very difficult to find the breaking point on where is the machine fast enough for aluminum, but strong enough for hard metal. That has been the challenge with all the machines we're designing.
Right, so one thing that's really become apparent to me, and it's really key in providing sort of greater than incremental change. We're talking of improvements of 50% plus. You know, this isn't small numbers. It's that there's a real need for collaboration, and I think industry are after a more holistic approach when it comes to providing big manufacturing improvements. And I know David Modig collaborate with key technology partners such as the likes of Seco, Renishaw and Siemens. I'm just wondering if you could just maybe expand a little bit more on the benefits and advantages of collaboration for yourself and for Modig, and how these partnerships work and how you work with them in a different way, maybe.
Mm-hmm. Oh, you're right. It's actually quite interesting, because I would say not all of them, and most of our suppliers are challenged by us, and they come to us and say the same thing, that this is really difficult. We haven't done this before. Should we really do this? And it's the cutting tool manufacturers, it's the control system manufacturers, it's everything really. So they use us. We have a very how do you say, high or big presence within even the biggest companies, because they use us as a test platform for the future. So that is really why we can guarantee these kind of cycle times, is that a company like ours, which is not extremely big, we have short decision ways, and we can design machines very quickly. So we're normally 4 or 5 years ahead of the normal size machine tool company. So that's why we also get the suppliers to help, and that's why we can guarantee this cycle time. So it's a collaboration between everyone.
Okay, that's great. Jürgen, you know, from a
Yes.
cutting tool manufacturer or cutting tool solution supplier, what are the benefits and advantages, again, of forming collaborations with companies such as Modig and working with the likes of maybe Siemens, you know, on the CAD/CAM or side of things, or control side of things? What does that not just bring to Seco, but also bring to our customers or potential customers? What advantages would they see from this kind of collaboration?
I mean, from our point of view, we also learn a lot about tool design here when we work together with Modig's application and engineers, and those learnings we also bring into our own organization for future development of new tools to make them even better. So I mean, this is, as David said, it's a very good, let's say, test platform for our tools. I mean, they are very early on the market with high-end machines. So if our tools work in a Modig machine, we know that it will work in other machines as well. Not saying that it's the vice versa. I mean, normal tool working in normal machine, it not always working in Modig machines, because we have completely different requirement there. So I would say that we can learn a lot by this cooperation we have with Modig.
Yeah, that's great. Thank you, Jürgen. So, I'm intrigued. What's next for Modig, David? How do you see the future of aerospace, of metal cutting and manufacturing evolve from where we are now, and what does that mean to yourselves?
I mean, with everything going on right now in the world, it's for sure a little bit unpredictable. We had two things going on, and actually, if we're outside aerospace, like I said, it was electrical vehicle market, which has been about 50% of the sales or more than that, which normally is not the case. We have 90% sales to the aerospace, so that has changed a little bit. But when you look at the aerospace in a whole, I would say that a lot of people think that aerospace is just commercial aircraft. But aerospace is so much more. You have the military, the business, the UAVs, helicopter platforms, and it's focus on the other industries where we're not so much present, not industries, but the other segments. And also when it comes to the machines, we do have two machines which is going to revolutionize the way of machining. We just got the patent for a completely new machine design, which the world has not seen before. And this is gonna, I believe, change the way of thinking of how you machine monolithic aerospace components.
Okay. So maybe a bit cheeky, when could we expect to see that, David? Or can you not say?
If you come to Sweden, I'll show you over a glass of wine.
Absolutely, sounds a great invite. Jürgen, same question to you as well. I mean, what do we see as Seco? How do we see things moving on in industry, and what does that mean to us as a solution supplier?
Quite a difficult question. I mean, as David said, the world is it's changing rapidly now, and the most important thing for us as a supplier is that we are changing with the changing we can see in the market today, and be responsive, reactive to the needs, so we can keep our, let's say, edge and being a reliable supplier. I mean, when Modig develop new machines, for instance, they will have new needs for tools as well, and we need to keep up with that. So we need to be very fast and responsive to the market needs.
And I guess that's where that collaboration comes in again, Jürgen. Instead of sort of reacting or responding to Modig's needs, that's where we collaborate and we actually work alongside them. So
yeah, I mean, yeah, the faster we can come into the projects, the more possibilities we have to provide good solutions as well to Modig.
Okay. David, so just as we come to a close on this, is there anything more you'd like to say about the machine or this particular demonstration or the technologies that Modig is showing in this video?
No, I mean, we're trying to get the Modig brand name out there, even if it's a 70-year-plus company. That is our struggle to get the name recognition. But the more time studies and the more parts we can look at, the more customers we will amaze. So I would say that's we need to be able to provide the customers with more time studies and more solutions. So as long as we get the chance, then the world will see where Modig stands.
Oh, that's brilliant. So we've been watching this video that's playing in the background. You've given quite a detailed tour of the machine and the features of the machine. Can people find this video somewhere so that they can watch it at their, in their own time and look at it in full?
It's actually a locked video because of the technology we're using here and talking about. But if there is anyone interested, feel free to contact us and we will set you up with a direct link to the video.
Okay, that's great. Jürgen, where can people find more information about Seco Tools and its solutions for aluminium machining?
I mean, we have our homepage and we have the different product areas. So I think that is the best way to find solution in aluminium machining, but also to contact your local representative for more advice around aluminum machining.
That's great. Is there anything that anybody else would like to add before we close this video or this session?
No, just wanted to thank Seco for the great partnership, and looking forward to the future.
Yeah, and then thank you too, David, and to Jürgen. Thank you for your time.
Yeah, thank you, Dave.
It's been great. So I think we've seen some great technologies and some great solutions. I think it was Aristotle that said that the whole is greater than the sum of its parts. You know, so what I'm saying is the individual parts, you know, when they're connected to form one entity, they're just worth way more than when we work in silos. And I think this is absolutely key when we connect what our customers are saying to what they're doing. And, you know, that understanding of their needs and our ability as two companies or more, whatever, you know, however many are in this collaboration, you know, our ability to respond to them is just improved exponentially. You know, we can provide world-class solutions and world-class collaborations and partnerships to our customers.